Hello. Firstly, I would take this opportunity to thank Professor Uday Khankoje for providing such a unique dimension to our learning experience of making this video on the numerical study of wave scattering. Wave scattering is a daily experienced phenomenon like reception of cell phone signal behind an enclosure. Or it also helps to explain the blue color of the sky. This so-called bending of wave depends primarily on the relative size of the obstacle to wavelength. In this simple experiment, we will play with this ratio and identify different regimes of wave bending using a very popular numerical technique in electromagnetics, namely the finite difference time domain method. Since the wave model is used to explain this phenomena and the rigorous computation of Maxwell's equations cannot be realized easily, hence FTDT is implemented using the software meep. When obstacle size is very small as compared to the wavelength, as is evident in the video, the wave impinges around the edges of the obstacle, giving the notion that the obstacle never existed there in the first place. The forward scattering created by the edges recreate the actual time harmonic wave which is incident on the obstacle. Next, we will discuss the case when the obstacle size is comparable to the size of the wavelength of light incident. In this case, the same size as the wavelength. Since the obstacle is a metal, we observe the Dirichlet condition to specify the values that the scattered field needs to take on along the boundary of the physical space of the object. This gives rise to the superposition of the scattered field and the incident field. Around an edge, its value gives rise to the bending effect. Finally, we discuss the case when the obstacle size is too large as compared to the wavelength. It shadows the incident wave due to the object being a metal as shown in the video. The scattering field of the edges in that direction is not profound and hence is neglected. This is an overview of the results obtained so far by varying the size relative to the wavelength. An obstacle of finite permittivity allows the field to pass through it as shown in the video, and hence the shadowing effect cannot be comprehensively studied and therefore we cannot observe the bending effect. This is a sample meep code which simulates the scattering of wave of wavelength 1 in meep units by an obstacle of dimensions 0.5 cross 0.5 cross infinity. Finally, this is the table which specifies the dimensions which help us to study the effect of scattering of light by an obstacle.